algebra textbook starts with lesson 1.1, which is a reminder about variables in algebra, probably the most important thing for the school year that you'll be working with. A couple reminders here on definitions, variable expressions, what they mean. Simply the two that might need some reminding would be multiplication and division. Remember, if you see a coefficient 8 and right behind it a variable, this time y, that's multiplication. You can also use the multiplication dot, and you could use parentheses. We no longer use multiplication sign like this. Whoops, near miss. Sorry about that. We no longer use the multiplication sign because it can be confused with x as a variable. For division, we can write it as a fraction because fractions are division. We can also use the division symbol still. And then addition and subtraction, pretty self-explanatory. So when we are evaluating an expression, we are going to write the variable expression, substitute any values that we have for the variables, and then we will simplify the numerical expression. If we are to solve, you will see an equal sign, and if it's simplifying, it will just be a statement. So a couple of these as an example. Example 1 is just evaluating the variable expression, so that means we will be able to find an answer without a variable. So 8y, and we see this time we're going to evaluate because we know y is being representative of 2. Y equals 2. So 8y would be 8 times y. That would be simply 16. 10 over y, that would be 10 divided by y, which is 5. We would have y plus 3, also 5, 2 plus 3. And 14 minus y would be 14 minus 2, which is simply 12. As we move on, they're going to remind us of a few formulas that are usually written as variable expressions, and then we look at the information given to us in a story problem to substitute some of the numerical values in for those variable expressions. So this time, I think usually you are used to seeing rate, which is the speed, times time. Again, we don't want to use the multiplication sign, but this is the way you usually see it. Having some problems with my pen, my stylus here. Let me see. Oh, well, it's squiggled for me. Okay, rate times time equals distance. That's very sloppy, but I think you can realize what I was doing. Now, I want to give you a little trick here as far as figuring out these expressions. You're used to rate times time equals distance. A good way to do this when you're trying to deal with something else, with a different kind of formula where you're trying to, this time we're trying to find the rate or find the speed. So a way to do that is to take your familiar formula of rate times time equals distance, even though it's very sloppy there, and to substitute some very simple numbers in for that. So I could say, let's do 2 times 3 equals 6. All right, if I know 2 times 3 equals 6, and you remember back to an old expression of family of facts, I can manipulate those numbers into a different order to figure out a new formula. So if I'm trying to find my speed or my rate, that was the 2 in this case. So how can I use my 6 and my 3 to get to 2? Well, I simply would change my multiplication sentence into a division sentence. So now I could say 6 divided by 3 equals 2. And that is what they did here. They took the corresponding variable, d, which was the 6 in my simple substitution. They divided it by t, the time, which in my simple situation was 3, and that should give you the speed. So now if we look at the actual problem here, we have 180 miles as our distance. and we have our time, 3 hours. So we know the values, and we can substitute the values of both the distance and the time, and we need to find out the speed. So our speed, what we're trying to figure out here, is going to be 180, the distance, divided by the time, 3, and our speed would be 60. Now word problem, so we need to have some kind of label there, and we see our label was miles per hour. Okay, manipulating some formulas. If you don't remember the exact formula, remember the little trick of just substituting some easier numbers in. Another formula would be to find perimeter. Perimeter is finding all the way around the outside, secure the perimeter. So the perimeter of this triangle, we have each of the sides labeled as variables. They gave us our formula in variables, a plus b plus c equals the perimeter. So we can go ahead and we can look at each one of those sides. So it would be 8 plus 15 plus 17 is going to equal our perimeter. And I'm going to use a couple tricks here. 17 plus 8 would give me my 25, and 25 plus 15 will give me 40. Now again, do we have a label for that? We have it in feet. So the perimeter, total perimeter would be 40 feet. Example 4 is going to give us simple interest. A couple vocabulary words you might need some reminding of. First of all, we have that money. Money is, the original money is that we have is called the principal. What we start out with is called the principal, or referred to as the principal. So the simple interest earned by money at an annual rate for a certain amount of time or years is given in principal times rate times time. So let's look at the information that we have here. We have 650, that's our principal. That's what we put in first. We deposit 650. The rate is at 8%. Now we're going to have to do something to that 8% here. And they want to know how much interest we will earn after 1/2 of a year. Okay, so after 1/2 of a year, and we're going to do something special with that as well. So 650, that one was easy, that was a whole number. 8% is in percents. 8% is the same as percent is always over 100. Get 100%, that means you get everything right on a test. So 8/100ths, and if we're going to use a calculator, which I would presume you would, we're going to change that to a decimal. So 8% is going to be 0.08. And then for 1/2 of a year, if we want to change that into a whole number, we're going to also use a decimal, so we can take advantage of a calculator. So to write 1/2 in decimal form would be 0.5. So in our calculator, we're going to plug in 650 times 0.08, and then we're also going to say times 0.5 for the 1/2 of a year. And when we plug that into the calculator, we end up getting 26. Now, one little reminder on these problems, make sure that you're using some logic in it as well. This is the interest we're going to earn. So if we put in $650, we're not going to end up with more than $650 in interest alone. This is just a little fraction that they're going to give us for keeping our money in the bank. So $26 seems like a pretty good amount of interest for 1/2 of the year. So if we leave that $650 in there for 6 months, they're going to give us an extra $26 for leaving it in there. That's a pretty good deal. And finally, our example 5 is talking about finding time. So we are hiking in the Redwoods, and we plan to go hiking in the Jedediah Smith Redwood State Park in California. We estimate that we'll hike at a rate of 2 miles per hour, we have a rate in there, on a steep trail. How long will it take us to hike from Holland Hill Road along the Boy Scout tree trail and back. So we're going to try to find time this time. So again, if you go back to your memory of rate, sorry about that, rate times time. Having some problems with my stylus again. It doesn't like rate times time equals distance. Doesn't like these problems at all. And this time we're trying to find time. Again, if you remember, I said 2 times 3 equals 6. So this time, if I want to know the time, 2 times 3 equals 6, I could do the distance divided by the rate. Family of facts again. If multiplying the two gives me the distance, I can take that total distance and divide it by one of those to get the other. So time equals distance divided by rate, which I am given both of those. The distance I have to find on the map here, and the distance tells me 7.4. So I'm going to say 7. I'm going to say it easier than I'm going to write it, apparently. 7.4. That doesn't look like 7.4 at all. If I can clean up my 7. Oh, cleaned it up, but it looks a little uglier, but you can definitely tell it's 7.4 now. 7.4 is our distance. Our rate is going to be 2, and so that should equal my time, and 7.4 divided by 2 is going to equal 3.7, and we look at what kind of label we're going to have, and it would be 3.7 hours because it's 2 miles per hour. Okay, so almost 4 hours to walk that very steep trail. That would be quite a workout. And that will finish lesson 1.1.